The precedence diagram method is a tool for scheduling activities in a project plan. It is a method of constructing a project schedule network diagram that uses boxes, referred to as nodes, to represent activities and connects them with arrows that show the dependencies and relationships. This technique is also called activity on node, AON, and is the method used by most project management software packages. The goal of the forward pass is to determine the earliest time that an event could take place. For example, what is the earliest that a project or activity might be started and finished? To show the data on the forward pass, two additional elements are added to the precedence diagram picture. The first element is the duration of each activity. The duration of the activity should be shown in the center of an activities node. The second elements added to a precedence diagram for the forward pass are the early time boxes. The early time boxes are placed within the activity node. These early time boxes refer to the early start and early finish of each activity. Early start, ES, earliest possible point in time on which a task can start. Early finish, EF, earliest possible point in time on which a task can finish. Once the forward pass has been completed, the second part of the critical path method, the backward pass, may be performed. The backward pass tells you the latest time at which an event can occur. To perform the backward pass, you will start with the last activity in the network and continue until you have reached the first activity in the network. The first step in the backward pass is to copy the early finish time of the last activity in the schedule to the late finish time of the last activity in the schedule. If you have a project completion date, then use the overall project completion date for the last activity's late finish time. Late start, ES, latest possible point in time on which a task can start. Late finish, EF, latest possible point in time on which a task can finish. The first step in the backward pass is to copy the early finish time of the last activity in the schedule to the late finish time of the last activity in the schedule. If you have a project completion date, then use the overall project completion date for the last activity's late finish time. Late start, ES, latest possible point in time on which a task can start. Late finish, EF, latest possible point in time on which a task can finish. Let us try to do this through an example. For the network diagram shown, we have to calculate critical path, slack for all the tasks. The customer wants the tasks to be completed within 25 days, so we also have to calculate the project float. Step 1. Draw a network diagram, forward pass, calculate the early start and early finish dates. Please note, Task 5 can begin only after Task 2 and Task 4 are completed. So, the ES for Task 5 is 17 days, because Task 4 can be completed only after 17 days. Step 2. Calculate the lengths of all paths and determine the critical path. The length of the first path, Task 1, Task 2, Task 5, is 17 days. The length of the second path, Task 1, Task 3, Task 4, Task 5, is 21 days. The critical path, or the longest path, is 21 days. Please note that we obtained the same result for EF for Task 5, that is 21 days. The critical path method, CPM, is a schedule network analysis technique. CPM was developed by the DuPont Corporation in 1957. Critical path determines the shortest time to complete the project, and it is the longest duration path through a network of tasks. Critical tasks, activities, are tasks, activities, on the critical path. It is an important tool for effective project management. Step 3. Calculate float in all tasks backward pass. Please note, for all the tasks on the critical path, that is, Task 1, Task 3, Task 4, and Task 5, EF equals LF and ES equals LS. Hence, slack for the tasks on the critical path is 0. Slack for Task 2 is 4 days. Step 4. Calculate project float. Customer wants an end date of 25 days. Hence project float equals total amount of time that the project can be delayed without delaying the externally imposed project completion date required by the customer. That is 4 days. Please note, the project float can be negative, that is, the customer wants the task to be completed sooner than planned in the project schedule. The project, then, needs to be crashed or fast-tracked.